right, I'm going to wrap up lesson 2.5 from the previous day on angle relationships, and let's talk a little bit about the developing proof. So in the course of the lesson, we discovered two conjectures that we could use. One being the vertical angles, where if I have two intersecting lines, then opposite angles, the vertical angles, are congruent to each other. Then we also have the linear pair conjecture, where if I have two angles formed and they share a common line, or actually the angles, we should share a common ray, then the sum of those two angles is 180 degrees. So what's the point of that? All right, we have these two conjectures. What am I going to do with that? Well, the idea is that we've used inductive reasoning to discover these two conjectures, and now we are going to use deductive reasoning to make some proofs, to determine some answers and things like that. So, for example, we have the linear pair conjecture and the diagram over here of the two lines intersecting. And we want to write an argument that can explain why angle 1 must be congruent to angle 3. Notice we're not using the vertical angle conjecture to do this. We are using the linear pair conjecture. So, let's take a look at that. Well, if angles 1 and 2 are a linear pair, right, we know this, because that's what they are, we can see. So that means the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. Now, so that's kind of step 1. The measure of angle 1 plus the measure of angle 2 is 180 degrees because angle 1 and 2 are a linear pair. So that's how the conjecture is working. Well, then step 2, all right, we have over here, let's change the color so you can see what I'm looking at here. My pen would like to pull up right here. I see that angle 2 and angle 3 are also linear pairs. Okay, so that means then the measure of angle 2 and the measure of angle 3 has to equal 180 degrees. We need to replace the battery in this pen. It's not writing as neatly. Well, then using algebra, for step 3, we know that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 1. Well, so using algebra, let's subtract the common variable from each side, and now we are left with the measure of angle 3 equaling the measure of angle 1. And congruency means that the measures are equal, and that means the angles are congruent. So, measure of angle 3 is equal to the measure of angle 1, so that means angle 3 is congruent to angle 1. That's deductive reasoning. It may take a while to get you there, but using the rules, using our conjectures, in this case the linear pair conjecture, we were able to prove that the sum of this was equal to 180, and the sum of this was equal to 180, and of course you had that overlap there, so it must mean 1 and 3 are equal to each other. Alright, let's move on to our next slide. So I'm going to clear off this screen. The converse of a conjecture, you might see this referenced every so often. And basically, converse means the opposite. If I were to reverse the conjecture, reverse those if-then statements, would it be true? So the vertical angles conjecture is, the vertical angles conjecture is if two angles are vertical, then they are congruent. Don't know why I keep doing that. Anyways, okay, so now we want to reverse that. So that means we're going to reverse this if statement with this then statement. And say, if two angles are congruent, then they are vertical angles. I don't even know why it keeps doing that. Very strange. Okay. So basically, we want to see, is this a true statement? And all we have to do to say it's a true statement or not is find one counterexample that proves it wrong. Because if it proves it wrong, then we know that it's not a true statement. So let's say I have a 45-degree angle here, and I have a 45-degree angle here. Are they vertical angles? No. They're congruent to each other, but they're not vertical angles. So that's one counterexample, one of many, to prove that the converse of this conjecture is not true. So if you're ever asked to prove a conjecture, or the converse of a conjecture, just flip the if-then statements and then determine if it's a true statement or not. That's pretty much it as the main takeaways from lesson 2.5. So be thinking about how those questions could be asked for you on your next quiz or test.